As you said, I'm a software engineer, so absolutely not a database administrator. I'm only a database user. And my presentation is about how we use in-memory technology for data warehouse and for BI. Here is the agenda we will go through. STEF is a 3 billion euro turnover company, a European leader in temperature control, logistic and transport services. And every day, the 19,000 employees work to provide our customer logistics solutions that comply with food security and lead times. Our customers are agri-food manufacturers, retailer, seafood industry, and out-of-home food service businesses like restaurant or wholesalers. STEF operation goes from production, collecting goods from industry and producer to our warehouse, where we can provide added value services such as storage, of course, but also order preparation, packaging, co-packing. We can also provide our customer supply chain optimization, control tower, and IT and digital solution. And we go to the transport to the distribution place, such as supermarket, wholesaler, restaurants. To help understand what STEF business is, we used to say that in a Western European country, everything you have in your fridge or freezer goes through STEF operation. STEF operates in 7 European countries: France, Italy, Spain, Portugal, Belgium, Netherlands, and Switzerland. We have more than 250 platforms on warehouses and over 4,000 vehicles to achieve our goals. And STEF also export and import from 15 European countries. So on all this platform and site, business manager need detailed and daily information to manage their activities. It goes from field sales to operation to operational controlling, human resources, purchase, and the BI team mission is to give all this manager the right information to support decision process and analyze in detail their activity. 10 years ago, we changed the BI team mission from producing reports for the business to deliver a centralized BI full self-service. In terms of database usage, delivering reports can be made by studying the query run by the report, added indexes when performance are not what we expect, even using hints for the query run against the database. When you provide a BI full self-service to your user, you do not know what queries they will make, so you change drastically how you design your database schema. And what we try to do is to limit aggregation against data to avoid losing information and to limit business rules that we apply on data. And we try to provide what I call a raw data modeled as a star schema with fact tables and dimension. Before using ImDB, our business intelligent information system was able to achieve this goal on low data volume area. When I mean low data, it's up to several million of facts a year. So of course for sales opportunity, customer service call, but also for employee time tracking or warehouse management, stock management and order management. But we were not able to achieve this on the transport management activity, which is the core business of STEF Group. And for this area, analyzing the transport, we were able to provide our user data mart updated once a week. We built a centralized information system for the last 20 years, and BI environment is built the same way. We have only one database that collect data from all the different applications used and deployed in the group. For example, SAP for finance, human resources, purchase to pay process and plant maintenance. All this data coming from SAP is collected and stored in the data warehouse database. It's also the case for the sales part coming from Salesforce with two modules that we use, sales management and customer services. So SAP, Salesforce are traditional application deployed in company, and we have a specific application linked to our business, time tracking application, and home build solution for warehousing management system and transport management system. The data volume of our data warehouse is 20 terabytes. Just to give you a global overview of our BI information system, we process all the data through a single ETL tool, which is the tool from Pantao Data Integration. And the production of the 200 ETL process is streamlined through one automation to manage our production. And data stored in our data warehouse is delivered to our users through three main solutions: IBM Cognos Analytics for reporting and self-services, Pantao Business Analytics for dashboarding, and Oracle Hyperion Planning for forecasting and budgeting. What was our journey of adopting a database in memory? We started in 2017 with a proof of concept. At that time, we decided to change our server, and we take the opportunity to study ImDB to work on performance we can deliver to our customer. Our proof of concept server was up to 700 gigabyte memory, and the version used was 12C. As our test was successful, we decided to invest in a production-like server with 3 terabytes of memory, and we try to take the existing data warehouse and upload all the tables in memory. but this was a failure. We did not have enough memory space to do this. So we spent the next part of 2018 refining our usage strategy, and we decided to split or partition our large table in two, with one partition we call warm for recent data, which is loaded in memory, and one partition which we call cold for older data and that will remain on disk. We also review our indexing strategy, because when you want to deliver full self-service to your user without in-memory, you need to create a lot of indexes, and especially in BI, bitmap indexes. And before adopting in-memory, the size of indexes was the same as the size of data in our Oracle database. We going to in-memory, we suppress all the bitmap indexes, and we only kept indexes with large cardinality, so near a primary key for each table. And in September 2018, we migrate to version 18C. Our go live of in-memory in production was done in April 2019, and the version used for deployment was 18.11. So at that time, we took the schema, the star schema we have, and we put it in memory with the refining I just mentioned. And in March 2020, during lockdown, we launched a large project on the transport analysis, activity analysis, the part that I mentioned before, we cannot deliver data daily. And in 6 months, we go live with a new data mart that I will explain in the next slide, which is the largest creation we did on in-memory today. But before that, in last April, we upgraded in 19C, and now our production is 1910. And there is important fixes that improve query performance in this last version. So let's focus on this data mart we just created the last year. Our goal was to give our business user a daily updated data mart on transport activity, from transport order to billing and after delivery services. So it goes through customer order, all the monitoring of unit load at each step of the transportation, with all the associated resource taking in charge the unit loads, human resources, of course, STEF human resources, but also subcontractors and all the vehicle in which we load and unload, or from which we unload the products. When STEF end with dealing with the customer product, there is of course invoicing, external and internal invoicing, internal between the different sites, credit notes and dispute management, and all this information is placed in one data mart to enable our business to analyze this activity. This result in 2 billion line fact table with 212 columns and 64 dimensions. And it represents more than 1 trillion, so thousands of billion information available to our business user. These data are daily updated, and data up to 7 a.m. are available in BI at 9 a.m. every morning. On the right, I added a graph where you can see how many operation we do for this data mart only on the database. Each day we are doing more than 100 million update, 10 million insert and delete on this only fact table. I wrote a white paper like document I call how STEF implements Ralph Kimball's best practices in Oracle in-memory database. If you are interested in, just ask me, I can share that with you. The idea was to document how we model our star schema and how we use in-memory in this type of usage. So what are the impact of using ImDB? For my opinion, or in my opinion, for business user, in-memory is even. Overnight, the performance of their query are divided by 10 up to 100. They have access to any information in seconds, even on a large period of time. Over a 2 billion line fact table, analysis takes seconds to few minutes. And it's really, as the previous speaker said, it's a game changer. For data engineer, in-memory is opening new perspective. Data volume and processing issue are postponed to the next level, but it's very important to work on the data model, and in-memory is doing the rest. And for database administrator, in-memory is a skill upgrade. Usage of indexes have to be reviewed and have to be reduced to the minimum. To give you an idea of our server, we have so just one server, 4 CPU, 8 cores, and 4 terabytes of memory. Our business continuity plan and disaster recovery plan are managed by DataGuard, and so all the transactions are replicated on a backup server to be able to recover from any problem on the first site. Some key number about our database. We have 19 terabytes of data today. Today we have 19 terabytes of data, 6 terabytes of indexes, and 9.8 terabytes of data are uploaded in memory, which took 2 terabytes of space in memory. Our database starting time is 9 hours. So I put a screenshot of the DBA command to see the size of our different in-memory area. What are the next steps? We want to continue developing new data mart on strategic area of our group for STEF. So all the doc activity data in the perspective of optimizing all the operation on data on a warehouse. Sorry. We are currently redesigning our billing part of our 360 customer data mart to give a billing section detail as it is in our transport data mart. We want to explore the usage of in-memory for advanced analytics purposes, such as activity forecasting or predictive maintenance. And also, we plan to collect IoT data to be able to expose and analyze the data coming from sensors to our business analysts. So for me, adopting in-memory technology is a one-way trip. For a business user, it saves time, it increases analysis capability. For data engineer, it breaks down some barrier related to data volume and time processing, but I think it's not magic. For BI, data modeling is the key. Load all your data in memory will not solve all your performance problem. As you listen to the different speaker, it helps solve a lot of performance problem, but not all on in my mind. And for database administrator, it's really not a big deal, just a skill upgrade. So before ending my presentation, just want to thank you, Oracle team, ACS with Christophe and the product team that help us in our project. And I want to thank you, the STEF teams, my team, of course, but also the DBA teams, Hubert and Eric, that works hard to make it work at STEF.